frick is this? Welcome back to Networking Tips with Dylan Clark. Now with more editing. Anyway, so last time I told you I would teach you about binary. Binary is how the computer talks with other computers. It is a form of zeros and one. That's it. It's a base 2 number system. You might recognize base 10 number systems, because that's what we do. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0. Basically, to do binary, I'm going to ask you to rethink how to count. So let's start counting like this. 0. We all start with 0. It's the first character in any number system. 1. Simple so far. We know 0 and 1 so far. Now watch this. 10. Not really. But easiest thing, that's what we call this so-called character, is 10. This is 2. 0, 1, 2, 3, 4, 5, 6, 7, 8. Not confusing. Let me explain this. See, the way that we count is we go up an integer every time we want to add a number. Every time we add 1. But when we get to 9, we're out of integers, aren't we? So what do? We go over 1 and we start again. That's all we're doing in binary. That's all binary is. Going over 1 and starting again. Except that we do it a whole lot faster than counting. Base 10. 1. No, I'm sorry. 0, 1, 1, 0, 1, 1. Like over here. See? When I got to 2, which does not exist in binary, no, you cannot have a 2 ever. Anyway. 1, 0. Because I ran out of numbers. And I started again. And then we just go over to the next place. Then the next place. And the next place. So, you might be thinking, but Dylan, I don't want to count that high for this. By the way, just pointing out these are dots. Anyone recognize that format? I'll get there. Anyway, so think of it like this. In the first column, let's make a little chart here. Make it have 4 columns. In the first column, what's the maximum number? Let's see, here we have 0 and 1, right? So the most you can ever get out of this column is 1, right? So whenever this column here is marked, what does that mean? Well, for example, let's say we have 1, 0. What is that? 2. And what happens if we have this column marked? It's 1, 1. 3. So the minimum requirement for this column is 2, because that's when we start adding numbers to this column. And let's say, what about this column now? You get 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1. That's 4, 5, 6, 7. Right? So the minimum requirement to get in this column is 4. Let's do the next column. So starting from there, that'd be 1, 0, 0, 0, like down here. This chart is useless. Anyway, so that would be 1, 0, 0, 0 through 1, 1, 1, 1. And if we add that up, that would be 8, 9, 10, 11, 12, 13, 14, 15. 8. Minimum requirement. 16, 32, 64, 128, 256, and dot, 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 dot. Nice little pattern, isn't it? Binary, base 2. Also can be represented like this. 2 to the 0, and anyone that doesn't know, anything to the 0 power is always 1. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and so on. But it might be easier to remember like this. I know when I'm working with binary, I'm not going to automatically think, oh, that's 2 to the fifth. So whichever way works for you, better. So let's take this. If you haven't recognized this by now, this is an IP address. So let's define it. Let's see here. There are 8 here. 8. 8 spots. Oh. That's like 8 bits in a byte, isn't it? After all, a bit is just on or off. Oh, that's just like binary. Amazing. So 8 bits, this is 1 byte. So let's see what's in that byte. So we have the ones column, 2, 4, 8, 16, 32, 64, 128. So that means that this here has 128 and 164. And the rest are left blank. So let's do some quick math. 192. Let's start here. 1, 2, 4, 8, 16, 32, 64, 128. So it has 128 plus 32 plus 8. So let's line this up better. 128, 32, here, 30, whatever the frick that was, 32, 8. So this would be 10, 18, 6, 1, 168. So what about over here? All zeros. So that's just 0. Look familiar, doesn't it? And let's take a look at this number over here. 1, 2, 4, 8, 16, 32, 64, 128. There's no 128. There's 164, 132, no 16, 18, and 11. That makes this number 10, 15, 10, 105. So this written out in decimal, or base 10, would be 192.168.0.105. That's my name. See? It's not as hard as it looks. Now, let me explain subnet masks. How a subnet mask works is that it's also a binary number.
So, let me erase all of this.
And a subnet mask, like I said last time, the default subnet mask would be 255.255.255.0. Let's define 255 in binary. Now, I know what you're thinking, but you just taught me how to get binary. Now you're already telling me how to subtract it? It's just as easy. So, we start at the top of our list. And remember, since we want 1 byte per data segment, or as we call it, octet, we start off with 128. Is 255 bigger than 128? Obviously. So let's subtract 128. So 255. Sorry. I'm horrible at writing. 255 minus 128. So let's see here. So make this 4. Make this 15. So 15 minus 8, that would be 7. 4 minus 2, 2, 1. 127. So, is 127 bigger than 64? Yes. Yes, it is. And if you might see a pattern here already, it's 63. But let's just prove it. 127 minus 64, 3, 12 minus 6, 6. Oh, it seems like a pattern now, don't we? So let's see here, 63 minus 32, 31 minus 16, 15 minus 8, 7 minus 4, 3 minus 2, 1 minus 1. So as you can see here, 255 is all ones. So as we would write this out in binary, it'd be 1111, 1111, dot 1111, 1111, dot 1111, 1111, dot 0000, 0000. Pretty strange, isn't it? Now, there's something special about subnet masks. Subnet masks cannot have a 0 in between ones. Subnet masks always start at the very left and will always be ones until it hits the first 0. That's what we call the Great Divide. This here's our Great Divide, because that's where the 1 starts hitting the zeros. That's about it. Anytime you ever make a subnet mask, it will be one of those. So, I'm going to be nice. I'm going to give you a handy-dandy little subnet masking tip. So, that means a subnet mask can either be one of these. Let's define them. 0, 128. Easy. See, 128 plus 64. 4 plus 8, 12. 6 plus 3, 9. 192. Like right here. So here, what's 192 plus 32? 4, 22. 224. What's 224 plus 16? 240. 248. 252. 254. 255. This is your handy-dandy subnetting possibility boxes. But remember, once you hit that 0, everything from then on kaput. Cannot be anything but a 0. And anything to the left of that cannot be a 1. I mean, it cannot be anything but a 1. So, let's write them on top of each other. 1, 1, 0, 0, 0, 0, 0, 0 for 192. 255. 1, 1, 1, 1, 1, 1, 1, 1. Dot 168. So that'd be 128. So let's see here. Let's take 168 and do the binary subtraction. 40. Can't subtract 64. So 0 minus 32. 8. Can't subtract 16. 8. 0, 0, 0. 1, 1, 1, 1, 1, 1, 1, 1. Dot 0. Stop. See that dot 0? Right here is where we hit our great divide. Basically, here's my family name. Everything that the subnet mask covers, that's why it's called a mask. It covers the IP address. This right here means that all of this will be stagnant throughout the network. That's how these two things relate to each other. This is the fundamental definition of a subnet mask. The rest over here is just x, 0, 0, 0, 0, 0, 0, 0, 0. This is your variable. This is the Dylan right here. Now, let's do an example. Let's say I want a subnet mask of our magic little number 192.0. That means, and let's say I have this thing here. Let's just make up. Let's just make this .1 now. So 255 dot 255 dot 192. So that means 128, 192. Here's my great divide, which means here is my network, which means that the first two zeros of anything my IP address is going to be will always exist. So, which means that we have a 0 and 128 and 64. So that means that we have an IP address range of 192.168.0.0 through 192.168.63.255. And I say .255 for this last octet over here because we can go from .0 over here because we, as you saw before I erased it, there's a dot over here because now we're in the third octet, because it can go from anything between 0.000.0.0.0.0 to 1.1.1.1.1.1.1, which we already know is 255. So congratulations, you know how a subnet mask works, you know how to binary, and next week I'm going to teach you how to network. Enjoy yourself.